Welcome to the Almost Rocket Science podcast, and this week we're very excited again to have Dan Johns, one of the engineers on the Bloodhound SSC project. So welcome to the podcast, Dan.
Hi Jeff, how are you?
Very well, thank you. And yourself?
Yeah, we're good.
Good. So you're working on this really exciting project, Bloodhound SSC. Why don't you give us an insider's perspective on it? What's it all about?
Okay. In principle, Bloodhound SSC is a new land speed record challenge. So the current land speed record is held by Thrust SSC, which is the first supersonic car, driven by Andy Green and led by Richard Noble. These guys got together and decided to have another go and create a car that could achieve 1,000 miles an hour on land. As the project developed, the recognition that if we made the project open source, we could use it to inspire a whole new generation with science and engineering. So fundamentally, the project is an education program, and it's about taking that project into schools and colleges and universities and allowing the next generation to actually be inspired with the technology within the car itself. So it's a very different approach to a land speed record, but principally, it's a really, really fast car.
Well, 1,000 miles per hour sounds extremely fast, so, man. So you're an engineer. How did you get into engineering? What really progressed you down this pathway?
Well, my earliest memories, I think, are from my grandfather, and I used to spend a lot of time in his shed, taking things apart. Not always with his knowledge that I was taking things apart, but I was always had an inquiring, mischievous mind, I think, as a kid. And I remember taking his lawnmower apart once when he was at work, and when he got home, he was initially quite upset. And then my punishment was to spend the weekend putting it back together again with him. And I think just tinkering in the garage with my granddad, making airfix kits and radio control cars. Those are my earliest memories of doing practical things as in a garage. So I think with everything I took apart and never fixed in my time, I had to become an engineer in the long run to fix everything I've broken.
That's very cool. Yeah, so, we know one thing is, at least in our country, and it seems that Bloodhound is doing the same ideas to try to promote that STEM education, that really push people into engineering. Why don't you tell us a little bit about Bloodhound and how it's doing that?
Well, we have, first and foremost, what we call an open education approach. We make the project accessible through all the modern digital channels. We have a culture within the project to tell everyone about the project and communicate everything going on about the car. And this means we can create some really, really rich STEM subject materials that schools can use. So we have 400 plus STEM ambassadors in the UK that use Bloodhound as a science reference, and they go into schools. They do workshops with children. We hold various seminars around the UK. We take the show car. We've got a full-size show car. We have this whole Bloodhound experience that just goes to different events. And we're, as a team, our education side is actually bigger than our engineering side. So there's nothing we can't really talk about with the car. So this is a completely different approach to projects I've worked on in the past in motorsport or aerospace, where you have a very closed environment where everything's very secret. This is the other way around, which makes us very accessible.
Wow, that's really cool. Now, since you guys are going for that 1,000 mile per hour mark, is there something special about the 1,000 mile per hour mark, or is it just an arbitrary number?
Well, the current land speed record is 763 miles an hour. If you're going to go for a new land speed record, then at that time, Thrust SSC's target was the sound barrier. That's a hard, no one's ever done that before. That's a very hard challenge. It involves a lot of developing a lot of new knowledge. It's inspiring in itself, the sound barrier, and we've done that. the next biggest number after supersonic really is 1,000. And if you go and say you're going to go for 1,000 miles an hour, it's the next biggest number. It presents some its own challenges. Breaking the sound barrier is one thing, but 1,000 miles an hour is 32% faster than we've been before. So it's actually the biggest increment on a land speed record as a target. If you said you come out and you're just going to go 800 miles an hour, it's kind of not that exciting relative to the existing record. So the 1,000 miles an hour is really a seemingly impossible big number to achieve.
Oh, very cool. Now, I don't know if I mentioned it before, but I'm a middle school teacher, and so one of the greatest things that I like about the podcast, too, is some of our listeners, including my students, get to submit questions to be asked. So hopefully you're up for these.
Okay.
Hopefully we won't tax you too hard today either. But
no, we usually get the most interesting questions from the students.
Yeah, you gotta love where that the mind goes. It's uninhibited, unlike our adult mind sometimes.
Yeah.
So, okay, so one of my students is going into 6th grade, so about 10 or 11 years old, and he wanted to be an engineer already, which we love. But he had a question for you, and he said, "What was your childhood dream?"
Wow, that's a really interesting question. I grew up after Neil Armstrong landed on the moon. I grew up in the 70s. My earliest memories really are of the 70s, and in those times everyone wanted to be an astronaut, and obviously the inspiration of the Apollo missions reached out across the world, and everyone I knew wanted to be an astronaut. And although I didn't, I think I was quite interested in maths and problem solving, and I think I must have intuitively known the probability of that as an aspiration was quite low. So I kind of I think I probably wanted to be a rock star, if I'm honest. So that I didn't achieve that, but I was always I think a very vocationally driven child, and was always tinkering with my bike or things in the shed. So it was almost a natural calling that I would go into sort of an engineering and science world. So I always had an interest in looking at how things work. So as a dream, I think my dream was to be a musician, and I did start playing some instruments, but I think the calling for doing something on an engineering and science level was just too strong.
Well, I gotta say though, in the world of engineering and the world of STEM, working on a project like Bloodhound, that makes you a rock star in our book, man. So.
Oh, thank you. Well, then we have quite a big band of rock stars. Then I'm quite privileged to work with some really, really great engineers and scientists.
Well, that's the best part, right? You need some musical accompaniment to make yourself such a good band. So.
Oh yes.
Same in engineering. You need a team. So.
And when we run a car, I think we'd be the loudest band on the planet at the time.
I'm gonna say that car definitely has to be quite loud.
Oh yeah. Yeah. We think it could be up. Just the rocket itself could be up around 185 decibels.
And forget the sonic boom, right?
And forget the sonic boom. Just the rocket's going to be loud enough.
That's going to be so cool. Another question is how did you get involved with Bloodhound SSC? I mean, or did you put in a resume? How did you get such a cool job?
Yeah, it's interesting. I worked in aerospace before this appointment. So geographically I was in the same town, so in Bristol. So I worked on various aircraft programs with Airbus. So the super, I think we call it the Super Jumbo, the double-decker Airbus A380 was a program I worked on. And so I was in the area anyway. So working in an R&D function within aerospace, you get to have a lot of exposure to things going on outside of your sector, particularly in universities and in other sectors. So I went along to a seminar, and it was held by Richard Noble, and he was presenting in Bristol at the local university, which was a university I support through my R&D world in aerospace. And I was just so captivated with this story of what they were going to try and do. And I then remembered watching him in 1983 achieve his land speed record of 633 miles per hour, and all these memories started to flood back. And it made me think, when I was watching this presentation, why did I become an engineer? And I think at the time, I'd worked so long in aerospace, I'd kind of forgotten that. And it took me back to those days in the shed, if you like, and actually just getting on with some inspired practical engineering. At the time, when you work in R&D in aerospace, what you do, you don't always see the results of what you do for maybe 10 years. And so I had all these questions in my mind why I became an engineer from listening to this inspired presentation from Richard. And it kind of just threw me a curveball, really. And so from that point on, I went and spoke to Richard afterwards and the chief engineer, and I used my technical team and technical capability that I was leading in aerospace to help support the project. And I got more and more involved in the project and less involved in what my day job was. So I kind of accidentally got into it because I got to the point where it became more important to me just to be doing Bloodhound than what I was doing in aerospace. And so I quit my aerospace job and joined the team. So that's pretty much it. So I gave up the pension and the career and everything and thought I'd go and do something crazy. But it's an Everest moment. Not everyone has a chance to do something in their life like climb a mountain. I don't have that aspiration, but this is, for me, my Everest, and I think it is similar for many people in the team.
Yeah, now I know Richard Noble can be quite convincing, and he certainly is very motivating. Did you have to bring your wife to along to hear the speech so that she would go along with this?
No. I think she knows my spirit is sometimes quite cavalier. I have come home before many years ago and just said I just quit my job because I want to do something different. And she said, "Okay, that's cool. You know, I'm about to go on maternity leave, and we've just signed up for a new mortgage, and you quit your job." Yeah. Don't worry, I'll find something. So we have this between us. We have this inability to sense risk, which we just do, which is it's probably quite a dangerous thing. I wouldn't advise anyone just quitting, but very supportive family, and we need that, all of us, in these kind of projects. We do spend long hours doing these things, and we're going to spend a lot of time testing the car next year, so we will be away from family. But as a project, we will recognise that, and we will support our families and bring them out and get them engaged in what we do. I've got two sons. They're they're very engaged in the project. They set up a Bloodhound school club, and it's part of their world now. So it's a family. It's very much a family-driven project.
Very cool. And instead of taking them out to your granddad's shed, a tiny little shed, where they can pull apart a lawnmower engine, you can take them to Richard Noble's garage and let them play with a huge show car and hybrid rocket engines, right?
Yeah, well, if my sons are anything like me, I won't keep my eye off them because they they won't help themselves. They will find something to take apart, and so it's really best I don't let them too close.
Yeah, that's funny. So yeah, I mean, do you have to pinch yourself every morning realizing that you're working on such an amazing project as Bloodhound?
Yeah, we talk about our technical centre as the Bloodhound Technical Centre. We nickname it the Doghouse, and when we walk in, and it is a shed. It's a shed in the middle of Bristol, next door to the SS Great Britain, one of Brunel's the first iron steamship, and we have this industrial backdrop around us near the harbour side. And so we're in this small brick building. We walk in. When the show car is there, it's the first thing you pass. You can't help stop and look at it, and actually, it reminds you, wow, this is what we're doing. And you do have that moment where you pinch yourself. And actually, when you go out to shows and you support going to these events, and you see not just children, but the parents and adults and other professionals in their technical professionals in their industry, and they come up and you see them and you see their faces, and they're just amazed at what you're doing. Those moments also make you stop and think that you're doing something pretty awesome. So we do feel quite humbled by it.
So this question may be a little bit more for Andy Green or even Richard Noble, but I'm sure you can answer it based on talking to them. So what is it going to feel like to be in the car as it goes from naught to 1,000 back to naught again?
Yeah, Richard Noble and Andy Green, only two people I know that would really be able to talk through that as they've done this before. Talking to them, they both talk about a phenomena where the faster they're going, the effect of the G load on them, they get to a point where their mind starts to play tricks, where they start to feel like they're actually driving straight down into, I suppose, the nose goes straight down, and they have to consciously tell themselves they're not actually driving vertically straight down into the middle of the earth. And that's something they talk about as that they've both experienced. Andy's his background as a fighter pilot. He's used to conditioning himself in his mind to deal with those G loads. He won't feel the shockwave in the car, and it should be much smoother. Surface of the desert is incredibly smooth. If you scale that surface down to the size of a billiard ball, it's as smooth as a billiard ball. So we're expecting he's going to have a pretty smooth ride. There will be obviously a lot of noise. There'll be some vibration from the power itself, but he's not going to feel a huge amount in terms of vibration. And the only experience he's going to sense from his previous experience is this feeling from the acceleration and then the deceleration, this sense that you're actually driving downhill. And other than that, we hope we're going to give him a smooth ride.
And how long is that whole ride going to take?
Well, this is I've sort of, in my mind, I've got an image of what I call a run profile. So from a standing start, he'll accelerate up to 1,000 miles an hour, and he'll do that in several stages. He'll start off with the jet running, and as the pressure builds up, it's actually quite a slow getaway, if you like, from the line. And as the pressure builds up, he can engage the reheat, and he'll have full power from the jet. As he reaches to around 300, 350 miles an hour, he'll go to start the process of igniting the rocket, and that's a two-stage process. He'll go through the mono sequence, where we start to decompose the HCP, and then we'll go into full hybrid and ramp the pump pressure up, and then we'll get the big flame out the back. At that point, he'll have full power, and he'll accelerate to 1,000 miles an hour. That whole process from 0 to 1,000 should take somewhere in the order of 42 seconds. He'll hold the power on through the measured mile. That will be 3.6 seconds. And then he'll turn the power off. The natural drag of the car will start to slow it down at 3G. So he'll go from positive 3G to negative 3G in an instant. Then we have the air brake doors. They'll be deployed. That increases the drag even further. We have 2 parachute systems. We're still not sure whether we're going to need to use them. We may get enough braking efficiency from the air brakes, but we will design the air brake, the parachutes in anyway. And then we have conventional wheel brakes. That whole process of slowing down takes somewhere in the order of another 40 to 45 seconds. So the whole run from 0 to 1,000 back to 0 again will be, he'll be, from a standing start, he'll be 12 miles away in 90 seconds.
You've given us great insight in Bloodhound, but maybe you can tell students or somebody who wants to be an engineer, maybe you can just give them a little bit of advice that you would leave them with a short tidbit maybe.
Okay. Well, I think, again, going back to what my journey on a personal level, and that really was, it started in the shed. I would definitely advise anyone to talk to their parents, to go to a junkyard, get an old lawnmower or a bicycle or something for a few dollars, take it home, take it apart, and just look at what's going on inside. You don't necessarily have to be able to put it back together again, but just that process of taking something apart is such an important first step, I believe. And that practical, inquiring kind of mindset will help you understand some of the features within an engine or, say, a bicycle. So I think my advice would be, go to the shed, take something apart, but get your parent or guardian's permission first.
Yeah, don't take apart the family lawnmower, or even worse, the family car.
No.
Oh, well, that's too cool, man. We got to really thank you for your time, and certainly you're living proof that with the right attitude, the training, and certainly determination that you can be a rock star in the STEM world and get a really awesome job. So we really thank you so much for your time today, Dan.
No, it's a pleasure. And, if anyone wants to get in touch with us, feel free. We've got so many resources on our website, and as a team, we always try and get back to anyone as well. So, follow us. I think we're all on Twitter as well. So I tweet quite a lot nowadays. That's one of something new for me this year. Was I became a I don't know what you call it, a Twitterer, I suppose. And if you want to volunteer, come along and get involved.